Hello, chemistry class. It is time to review chapters 9 and 12 on your exam. And we're going to be going over information that we talked about in January. Now, that was a little while ago, so odds are that you forgot a good bit of it. I've linked the PowerPoint and a couple worksheets in the description of this video. So if you feel pretty confident in your ability to read and understand things for yourself, you don't even have to watch this video. You can simply just go and start looking at it yourself. But if you might be kind of concerned about your knowledge of these things, we're going to breeze through this entire PowerPoint in about 15 minutes along with a couple of videos. And this is going to help you kind of prepare for the exam you're going to be taking. Let's talk about what happened in chapters 9 and 12. First of all, we talked about bonds, how they can be single, double, and triple, but not quadruple bonds. We talked about types of bonds. You have ionic, which happens between a metal and a nonmetal, like sodium and chlorine, salt, table salt. The sodium gives away its electron to chlorine. You have nonmetal. Two nonmetals together is a covalent bond. This would be, for instance, a carbon bonded to like an oxygen. And metallic is where you have metals just randomly sharing electrons. We talked about polarity and how things don't share equally. For instance, if a hydrogen shared with an oxygen, the oxygen would get the better end of the deal. The oxygen would get the electron probably 95% of the time. Whereas a hydrogen, it just doesn't have that strong of a pull. This is going to be a polar bond, whereas this here is nonpolar. This here, it's kind of close. I'd say it's probably nonpolar too, because fluorine and chlorine are very equally matched. We talked about molecular shaping and the VSEPR system, how you can have linear, trigonoplanar, tetrahedral, etc., and how they shape the molecule in a 3D type pattern. We have intermolecular forces, such as dipole-dipole, which affects things that are polar. We have London forces, which affect all molecules' weak temporary bonds, and you have hydrogen forces, or hydrogen bonds, which affect hydrogen when it's bonded to something highly electronegative, like oxygen, nitrogen, or fluorine. We talked about the Lewis dot structure, how we can, for instance, for this guy here, how carbon is double bonded to oxygen and double bonded to another oxygen, and how oxygen already has 6 valence electrons, so it only needs 2 bonds, and how carbon has 4 valence electrons, so it needs 4 bonds, and this allows carbon to be filled in its octet rule, just like oxygen. Predicting the shape, this will be trigonal planar. Well, why? Because it makes 3 bonds. We talked about solubility, miscibility. Is it miscible or immiscible? Soluble and insoluble. Soluble deals with solids and liquids. Miscible deals with liquids and liquids. We dealt with types of things that will affect a chemical reaction's rate. Activation, energy, temperature, concentration, surface area, etc. We talked about exothermic and endothermic reactions, and this is really where things get messy. We talked about molarity and molality. Does anybody even remember molarity and molality? Molarity deals with moles of solute and liters of solution. Molality deals with moles of solute and kilograms of solution. We're going to do a worksheet on molarity and molality in just a second, where I'm going to just run through a couple of ideas. We ended up talking about electrolytes, how things that dissolve to produce ions also produce electrical properties. osmosis, where there's a net flow of water into something, and mixtures and a couple odds and ends there. And that's just about all of chapters 9 and 12. Let's talk about molarity and molality. I'm going to do just a couple of practice problems. Okay? 2.5 moles of sodium chloride is dissolved to make 0.5 liters of solution. And let's see, how am I going to even do this here? Let's pull up a blank slide. And this is a pretty good way to do it. Here you go. So 2.5 moles of sodium chloride, 2.5 moles over 0.5 liters of solution equals the molarity. That's a capital M, by the way. It's supposed to be bigger. And 2.5 moles divided by 0.5 liters is a 5 molar solution. I'm going to abbreviate solution. Good. All right, number 3. We have grams instead of moles. Ugh. So we have 18 grams of solution. We need to get grams into moles. Grams to moles you actually divide. We need to figure out the molar mass of hydrochloric acid. Hydrochloric acid is HCl. If we take a look at the periodic table, we learn that hydrogen's molar mass is 1, chlorine's is about 35. You add those two together, and you get 36 grams per 1 mole. When you divide these things, remember in algebra we learned keep, change, flip. So we keep, we change to a multiplication sign, we flip, and now we have 1 mole over 36 grams. Whoa, that went a little crazier than I thought. Grams cancel out. 18 divided by 36 is 0.5 moles of HCl, and we're given 0.5 liters of this solution. Well, 0.5 divided by 0.5, this is a 1 molar solution of HCl. And number 5, this will be our last one. Let me grab a new slide here. Let's see. We have 734 grams of Li2SO4. Li2SO4. And we have 2,500 milliliters. Now, molarity is moles of solute over liters of solution. We don't have either. We can find liters of solution pretty easily by dividing by 1,000. That'll give us the liters. So it's 2.5 liters of solution. But now we need to get from grams to moles. We divide. We need to find out the molar mass of lithium sulfate Li2SO4. Molar mass calculator. How about that? You ready? We're going to trust a random thing we're going to find in Google. Li2SO4. Calculate. Really? Li2SO4. Hey, 109.94. Not too bad. I guess I had to add the capitals. Good. Hey, it deleted it. That's the guy I remember. So we have, let's see, we have 734 grams, divided by 109.9 109.9. Let's see, let's ask Siri. 734 divided by 109.9.
The answer is about 6.6787.
6.787 moles of solution, and divided by, it was 2.5 liters. 6.687 divided by 2.5 liters.
It's 2.6748.
2.67 molar solution of Li2SO4. Anyway, I'm going to include this, and hopefully if you don't get it, you can rewatch the video and kind of relearn it. Of course, on your exam, I'm going to give you a very basic example because I just have to touch on everything that we've done. If you don't get it, Skype call me. I'll walk you through a couple more examples. It's okay. You're not going to sound, ignorant or anything. This is hard stuff that we did 4 months ago. And we've been out of school because of quarantine and corona for a good month and a half now. And so odds are you probably kind of forgot. That's okay. But you're going to have to know for the exam. So let me know. I'll see you guys later. Have a great day.